2022, and we're going to talk about our STEM project that is EvolveEd. First, I'm going to give you a little introduction before we get into the theoretical part. So I'm sure that sometimes in your life you have not liked the subject just because the teacher is just reading the slides or simply he doesn't show interest in what he's teaching. So a robot is an educational robot with educational purposes that contains sensors, motors, and all for the students to learn about it. Now, this robot is planned for middle school, elementary school, and high schoolers to learn the skills and to obtain skills about assembly and programming of robots. Why? Because we think that since now there are so many technological advances and people with knowledge about assembly and programming robots will be needed.
Prototype. This is image of prototype. You can see the idea of the beginning is from they have a propeller on the top, and the idea originally is to make the robot pitch with energy generated by the helix. Measurable physical characteristics. First, displacement. You can measure the distance the car travels by putting one point to another. 2. Distance. It can be measured by marking a starting point from the carriage by an advantage to the point where it will arrive. 3. Speed. It can be measured by timing with a timer how far the car travels, maximum speed, or from the one place to another. 4. Application of forces. It can be measured by saying if at the moment of moving forward there is a force that slows down the movement of the car instead of change speed. 5. Consumption or transformation of energy. It's possible to measure the amount of energy consumed as the energy is generated. When it takes the car stop moving as soon as the wind energy removes. In real life prototype. This is our prototype in real life. They have a propeller, and this image shows the first prototype that we have.
Okay, this is the theoretical framework that we made. We are going to talk about the key concepts, the explanation of these concepts, the background research that we have made, the characteristics of our project, and relevant significant laws or regulations.
So first, the key concepts. First of all, to better understanding this project, we have to learn how energy is transformed into mechanical energy. Our generator is a DC motor that is right here, you can see it. With this, the commutator, it needs, this is like an electromagnetic field. When it spins, the electromagnetic field generates energy, and with the cables, put it, right here is put it onto a LED, but it can put whatever you like.
Explanation. We consider this concept as technical since we are talking about a circuit of movement mechanism which contains both DC motors and cables that connect different poles of currents, as well as a structure that has to have the car. And with wind energy, generate and turn on the LED light. While it is in motion. Speaking of DC motors, we are also using scientific terms. Since DC motors work with an electromagnetic circuit to be able to both generate and absorb energy for its operation, being this part of what we see in the science of physics.
Background investigation. This project has been taken to a large scale, developed by 5 students of the transportation design of the IED of Barcelona. Called Tesla T1 to the first, based on a wind turbine. Based on the wind turbine. Called Tesla T1 to the first, based on the vertical turbine.
Remember, this is supporting material.
Okay.
That's the reason that we use that. Because if you forget something, you can look or not read everything.
Where four individual turbines are included on each wheel. The system is estimated to produce 1,000 kilowatts of power, and we have not encountered any problem with our project, only the cost of the material.
Okay, the characteristics. With all this information, we can realize the main characteristics of our project. For example, the speed. The car is driven by 4 engines, making a speed of about 5 kilometers per hour and a mass of 500 grams, and is able to move forward, backward, and sideways. All these characteristics are related to each other because, for example, if we change the motors for some with more power behavior, then the speed of the car will decrease because as a result of the weight we are adding, and also as well as we make it lighter.
Scientific laws. The project is in stake with the 3 laws of Newton and the law of conservation of energy. The first law of Newton, because when the car will stay without motion unless a force is applied on it. The second law of motion, because the acceleration and the speed of the car depends on the mass. The third law of motion, because when the car moves forward, it will create an energy pushing backwards. And finally, the law of conservation of energy, because the energy that the wind turbine creates is transformed to motion, that is kinetic energy.
Now I'm going to talk about the variables. We have the independent and dependent variables. Then independent will be the distance that travels the car, and the dependent how many energy does the DC motor do when it moves. Now this means that the helix made and how many volts it make for it to turn on the LED. We need about 3 volts to make it turn on, and yeah. Also, we made up forms of measure how effective it will be to use this robot in school, and if we be interested to learn with it. This is the forms. As you can see, many of the responses are totally agree. So we think that our project has potential to make it on the schools.
We use the SDG number 4, quality education with purposes to innovate of the field of education with new learning methods. And also we use this SDG number 7, affordable and non-polluting energy. Since with the propeller we generate energy to trace the LED light and thus indicate that energy generated. By using these 2 SDG, we are helping to not pollute the environment, and also we are helping the education of students, giving them more knowledge about robots, and this can help them in future occasions.
Okay, the contribution to our initial problem. These prototypes will help teachers to explain topics as wind energy, the function of ultrasonic sensors, and line tracking sensors, and how each one works. Also the DC motors, how work when we put in a car, and how they also can be used to generate our energy. And finally, the concepts of physics and mathematical, such as speed, acceleration, distance, and the resistance generated by the helix with the movement of the car. Also, the remote control makes easier to the students to manipulate this car, and making it fun for them and easier to understand it.
So for you to see that it actually works, we're going to put it here, and with the remote control I'm going to make it move forward. with this, you can see any type of child can use it and learn how it works. So that's how. And also, we want you to know that the LED works too. Right here, it actually works. Even that, obviously, we're not going to use that mute because we need more power in the DC motors, but these were like the cheaper ones. So if we want to use that power of wind, we have to buy more expensive ones, and we don't have that money. Those are the appendices. This is where I was assembling it. It has instructions and everything clearly, so you can read it. It's not that difficult.
In conclusion for this project helps the students to reduce the lack of attention that have in class. And as the conclusion for the process we have to our project, we constantly we're looking for solutions to problems we encounter.
And that's it.
Thank you for your attention.